Here. No, I got this. You're on the computer. Okay. If it ever comes up. No, slow. Okay. So, aquí estamos, hoy es febrero 3. ¡Yeah! 2 días más de clase nada más, estamos en el laboratorio de ciencia Thomas Farrington, ¿ok? Estamos hablando de los cambios a la superficie de la Tierra, ¿verdad? Estamos hablando de lo que es degradación, erosión y deposición, ¿correcto? ¿Verdad? So today we are talking about what three parts take part of the slow changes to the Earth's surface. Weathering, say it out loud. Weathering, erosion, deposition. So what happens when, with the wet, hold on, let me change the view to camera so that my friends online can see what happens. Alright, so let's change it, and then everybody stand up. Everybody stand up, and then you're going to show me what weathering does. Weathering, breaks it, show me. Weathering, breaks it, right? And then erosion, moves it, and deposition, drops it, right? Drops it. Okay, cool. So again, let's try one more time. ¿Qué hace la degradación? Lo rompe, la erosión lo mueve y la deposición lo tira. Perfecto. Okay. Okay. Very nice. So we're going to focus today on the effect of glaciers and slow changes to Earth's surface. Hoy nos vamos a concentrar en glaciales y los cambios que tienen a la superficie. Okay, and so the activity that we're doing today, I'll put it up on the... Okay, y la actividad que vamos a hacer en el día de hoy. First, we're going to watch a video. Vamos a ver un video. Then we are... Oops. Let me roll that. Can they still see it? Okay. Then we are going to... Oops, what did I do? Oh, Mrs. Farrington. And when I moved it, I must have. There we go. Oh, there we go. Okay. So el texto dice, rómpelo y muévelo. Okay. Okay. And then, I have a few pictures that will help you to explore. Tengo varias fotos que nos va a ayudar a explorar. And give some attributes or qualities. Que les da cualidades. And then you are going to compare a V-shaped valley and a U-shaped valley, and we'll talk about what causes both. Okay, entonces vamos a comparar un valle en forma de V, un valle en forma de U, y comparar qué es lo que causa que cada uno se vea así. But the best part is you're going to make a model with Play-Doh. Pero la mejor parte es que va a ser un modelo con plasticina. O sea, si usted está en su casa y tiene plasticina, puede hacer este modelo, mostrarle una foto para crédito como el día de hoy en la clase. Okay, and I think we'll try to do both so you can see the difference. Y creo que vamos a hacer ambos para que puedan ver la diferencia. Okay, so we have to move quickly. So nos tenemos que mover rápido. Okay, the video? Okay, el video, denme un segundito. Alright. Uh-oh. I think I can have it on. Okay, source of, yeah. Yeah. Come on. Oh, here we go. It's probably not going to work. Come on, PBS. Why is everything so slow on here? Oh, there we go. Closed caption up.
Here's something we all take for granted. Liquid things flow like liquids, and solid things flow like, well, solid things don't flow, right?
Okay, so el líquido fluye como líquido y las cosas duras no fluyen.
How do people they're made of ice? I'm here, measuring all this.
What is this? Okay. Alright. Sorry, I can't slow it down.
One of about 40 glaciers in the ice sheet. Listen to music because the way that they move, listen to very fast that they move. It seems to defy physics. It's a solid that flows like a liquid. How? That's the question of glacial proportions. To figure out how a glacier moves, first let's go back to the beginning. Not that beginning. The beginning of the glacier. First, we've got to get up there. I'm super excited. I've never been in a helicopter before, and we're going to take this thing up to the top of the glacier. Just like snow. This ice is born in the ocean. Warm, moist air from the Pacific rises up coastal mountains where it cools, condenses, and falls as snow and rain. 30 meters of snow, sometimes more, falls in this ice field every year. You need more than a mountain of snow to make a glacier. You also need the right climate. Even in summer, it's summer here right now, even though it doesn't look like it, it gets below freezing here. And what that means is the accumulation of snow in winter exceeds the snow in summer. And this lets the snow pile up layer after layer every year. A cubic meter of snow weighs anywhere from 70 to 150 kilograms. About the same as 1 or 2 years old humans. But most of that volume is air. As it piles up, the collective force on all of that fluffy stuff begins a transformation. Working hard here. First, all those pretty little snowflake shapes are totally shattered into smaller grains. As they're packed together, the air pockets between them shrink. The snow becomes denser. After about 2 years, ground snow transitions into a new form called firn. Firn is an intermediate form between snow and glacier ice. It's about 2/3 the density of water, and it can take many more years for that to transition into its final form. That final form is a big mass of dense, bubble-free ice. The ice in Mendenhall Hall is flowing forward more than a ½ meter every day. Glaciers are often compared to rivers of ice, and that's not wrong. These giant solid structures behave with liquid-like tendencies. I know what you're thinking. Ice moves because it melts, but glaciers can move without melting. Mendenhall is pretty solid. I mean, I can jump up and down on it, it doesn't deform it, but these short-term stresses don't do anything. Long-term stress, like bearing its own enormous weight, can bend and deform this ice. What we're told makes something a solid rather than a liquid is that its atoms and molecules are so tightly bonded they can't move past each other. But this isn't the case with glacial ice. Its water molecules are arranged in an orderly pattern, but under certain conditions, they can still flow. Much of this has to do with the pressure melting point. As pressure increases, the melting point of ice decreases. When glacier ice stays close to but just below that point, it becomes malleable, much like how you can bend and deform solid metal when it's heated near its melting point. Watch out for that. The deepest layers of the glacier are subjected to the lowest pressure. That's the zone of plastic flow, because the bonds between the ice crystals can be stretched rather than broken. Here, the molecular bonds between ice crystals actually stretch and slide past each other rather than break, like how a deck of cards deforms as cards slide past each other. When the bottom of the glacier needs to move around large obstacles like boulders, even higher pressures on the uphill side cause the ice to melt, float around the obstacle, and refreeze on the other side. As these processes continue, the glacier creeps along, propelled by gravity, like some giant green conveyor belt. Right here in the top of the glacier, this upper 150 feet or so, that's the zone of brittle flow. When the ice isn't under much pressure, so when it's stressed, it's prone to cracking. So now you see these beautiful crevasses and things like this. the top has to curve farther, faster, so it cracks or the body bends and stretches. Some glacier movement comes from slipping on sediment or a thin layer of water, but most glaciers not at Earth's poles move by this process of deforming. Glaciers are a product of climate, and they change with the climate. Mendenhall Glacier is currently slinking along a 13-mile journey to its lowest point, Mendenhall Lake. The terminal edge of a glacier is one of the easiest places to sense movement in action, but it's also where we can see how much things are changing. Glaciers never move backwards, and they're always melting. But when mass melts away at the bottom faster than new mass is added up top, they can recede. It takes about 200 years for new ice to move from an ice field down here to the lake. That's a slow process. But warmer summers combined with less snowfall in winter mean that things are speeding up. The glacier is retreating faster than it's growing. Where I'm standing today was covered in ice just a few decades ago. Glaciers like this are an example of climate change that we can see in our own lifetimes. The 50 can have a move is really cool, but for that to keep happening, they have to stay that way. Thanks for watching, and stay curious.
Whoa. Okay. So, do we want to read together that article? We can. Would that be better, or no? They can read it. Oh, and I couldn't copy and paste it. Okay, in your group, you're going to read the text. I said there's 3 paragraphs. Perhaps one person can read one paragraph, and then the next person reads, and then the next person. So everyone has a chance to read. Pay attention to the bold words. What does that mean if the words are bolded? When you read something, what does that mean? Are they important?
Yeah.
Anything that's bolded, they want you to learn. And so, weather, erodes, deposition. Those 3 words. So, could we consider them vocabulary? Yes, that they're vocabulary. So, you brought your notebooks, right? So, on a new page in your notebook, let's write the definition of those 3 words when you get to them. So, what are the words? Weather, erodes, deposition. And those words are the sentence that they're in is the definition. So when you read it, you'll see that, for example, glaciers, weather, in parentheses it says break down rocks as they move. So what does weather mean? To do what? They're not talking about the conditions outside, like today's weather is warm, right? They're not talking about it. They're talking about it in the same way that they talk about what other words you're familiar with.
Weathering.
Weathering. So weathering, so it's a, how do I explain? I don't know how to explain this in Spanish. So it's a tense of, to weather is the process of weathering. So if something's, so if they're just using the same word, it has the same meaning. It's just the way it's used in the sentence. Just, it doesn't, I don't know how.
It's different words.
Weather and weathering.
Yes, it's not the same sound.
So,
Cuando algo se degrada o cuando algo es degradación, okay, so uno es el verbo, ¿verdad? De lo que está pasando y el otro es, ¿qué sería? ¿El qué? So la acción, ¿verdad? So degradar y degradación. So cuando estamos hablando, como por ejemplo, algo está degradado, significa que algo está roto, ¿verdad? Algo se rompió por el clima, ¿ok? ¿Entendemos?
So it's just present tense in English, right? So to erode, the glacier erodes, it moves. Instead of erosion is the movement of sediment. So it's just using it in a different sense. So when you read it, write the word,
And in parentheses, right, next to it is the definition. Okay, so take turns reading and we'll come around and help if you need it. So,
ok, so hasta aquí entonces llegó la grabación de el día de hoy de ciencia. Si usted, voy a tomar fotos del producto que usted tiene que tener final y entonces usted va a continuar la agenda de ciencia para completar el resto de las cosas que están en la agenda de ciencia. Gracias. So we can put it here and they can see it. Oh.